Hey everyone, welcome to my channel. In this video, we are going to learn how to use gesture control to change the volume of a computer. We will first look into hand tracking and then we will use the hand landmarks to find the gesture of our hand to change the volume. This project is module based, which means we will be using a previously created hand module which makes the hand tracking very easy. I have created an ecosystem of modules that can be used in various robotics and AI applications. To learn more about it, check out my premium course on Jetson Nano in the description below. So let's get started. So here we are in our PyCharm project. This is the same one that we used in the previous video. So in the previous video, we learned about hand tracking minimum code, the bare minimum code that is required to run hand tracking. And then we created a module out of this so that we don't have to write it again and again. We can simply import this module and run it as it is. Now, if you haven't checked this video, I highly recommend that you go and check that video out first. And then you can come back here and we will continue with the hand tracking project. So the project that we are working on is the, let's call it volume control, or let's call it volume hand control. So we are going to control the volume of our computer with our hand. So that is something very interesting. Now the first thing is that we will go to file and we will go to settings. We will make sure that our libraries or packages are installed. So we will write here OpenCV Python. So this is the first one that we need. We will hit install and then I've already done it. That's why I'm not doing it. Then we are going to write media pipe and we will click on that and we will hit install. So these are the two main libraries that we need for now, and later on we can check what we need afterwards. The first thing you have to do is you have to import your packages. So we will write here import cv2, then we will import time, and then we have to import numpy as np. So these are the basic packages that we will be using. Later on we will add some more as well. So the first thing we want to do is we want to check if the webcam is working and everything is running fine. So we will write here that cap is equals to video capture cv2.video capture, and we will write the ID number. So I'm using ID 1. Most probably you will need ID 0. Then we will write while true. We are going to check the success of the capture, and then we will write image, and then we will write cap.read. So this is the main idea, and then we will write cv2.imshow. We will write the image and then img, and then we will write cv2.wait key as 1. So that will give it a 1 millisecond delay. So this is looking good. Let's run it and see what happens. There you go. So this is my hand that we will be tracking, and we will change the volume from, and this is our webcam. So what can we do? Okay, one more thing we can do here is we can write here, let's say this is the part where we have our parameters. So we can write here that our cam width, let's write width of our camera, and the height of our camera is equals to 640 by 480. So we are basically defining it here, and then we can use it here. We can say cap.set prop ID number 3 is width. So we will write width cam, and then prop ID at number 4 is height cam. So we can write height cam. So that should be good. And let's try it with the different value, 1280 by 720. So this will make it a little bit bigger. Yeah, there you go. So but we are going to use 640 by 480 instead. Okay, so that is good. What else can we do? We can add the frame rate. So here we are going to write that our current time is equals to time dot time, and then we have the FPS is equals to 1 divided by our current time minus the previous time, and then previous time is equals to current time. So we can define the previous time as 0 over here. And what else? So now we can put this FPS on our image. So we can write here cv2 dot put text, and we will write image, and then we will write FPS, and we will write the value of the FPS, let's say integer FPS, because it's decimal, we don't want decimal places. And then we can write the location 70, and then we write the font. So we can put any font that we want, and then we will write the scale and the color. So let's write 2550255, and then we will write the thickness. So that should be good. So let's run this and see if it works. Oh, it does work, but looks really bad. Okay, so first of all, the color is bad. So let's change it to blue. So we can remove this. And then let's try the blue color first. Yeah, the blue color is much better. Then we can make it smaller. It's really big. So scale, let's put it as 1. Yeah, that seems good. Thickness is fine. I think it's fine. We can reduce a little bit, but, and then we can push it up a little bit. Let's say 50. Yeah, now it really looks good and in the correct place. Okay, so now that we are all set, now we will do the magic part. The magic part here is that we already have our hand tracking module, so we don't have to write a lot of code. We will just use its functionality, and we will be able to get our hand very quickly, the landmarks of our hand very quickly. So we will write here import hand tracking module. Now, if you don't see hand tracking module, that is because you need to put it in the same folder as your project. So if it's not in the same folder, or if it's not even here, then you will not be able to use it. So you need to make sure it is in the same folder. And we can import it as something else, HTM, let's say, hand tracking module, because we don't want to write that complete name. It's quite big. Okay, so then we will create an object. So this is a class. Inside here, we have a class. Where is it? Here, hand detector. So we will create an object from it. We will call it detector. Detector is equals to, what was the name? HTM dot hand detector. And then we have our default parameters already here. So we don't need to write anything for now. So we will keep it like that. And then what else can we do? Then after doing this, we need to find the location, or we need to find the hand. So we will write here that detector dot find hands. So this is the method that we created. So this is this method, find hands. And all we need to do is we need to send in the image. So this will give us the hands. So we want to draw it, so we will not put it as false. We will keep the draw as true, and it gives us the image back. So we will accept that image back again. So that is pretty much it. So we can separate this code, not too much. We can separate this code so that it is easier to read. So now we can run it and see if it works. And there you go. So now we are getting good detection. and it seems quite good. So what happens sometimes, you can see it detects a little bit on the side and then it detects small hand as well. So what we want to do is we want to change the detection confidence here. So at default it is 0.5. So the detection confidence is 0.5. We want it to be really sure that it is a hand and then only detect the hand. This way, when you are changing the volume, it will be a little bit smoother because it will not flicker too much. So we can write here detection confidence is, let's say, 0.7. So you can play around with this value if you want, but I will keep it at 0.7. Yeah, seems fine to me. And then we are going to go to the next part, which is the best part of getting the position. So now all we have to do to get this position is to write that our landmark list is equals to detector dot find position, and then we just send in our image. That's it. And we will also write draw is equals to false. We don't want to draw it because we are already drawing it. So we will keep that as false. And now let's run it. And there you go. We are getting it, but I forgot to print. So print LM list. So let's run that. And there you go. So at the bottom, you can see that we are getting that list. So here we are getting that list. And we have a total of 20 values here. 21 values because we are counting 0 as well. So we have a total of 21 values. Now, if we want to get the value of a particular point, then we can write that point itself. So here, for example, we need point number 2. So this is the landmark number 2. So if we run that again, okay, so this is a good point. We are getting an error because the index is out of range. So before we actually print or before we actually do anything related to the points, we have to make sure that there are some points. So we will write here if LM list, the length of it is not equals to 0. Not equals to 0, then we are going to do this. Otherwise, it will skip it. So let's try that. And there you go. So now I'm only getting landmark number 2. So this is good. But how do we know which landmark do we need? So here is the MediaPipe website, and they have given us the landmark model information. So these are all the values that we get, all the landmarks that we get. So here we will need the value number 4, which is for our thumb, and we will need the value number 8, which will be for our index. So we need the tip of both the thumb and the index. So we will go back here, and here I can write I need the value number 4, and I need the landmark list. I need the value number 8. So this way we will get only these two values. There you go. So now I have these values and you can see they are changing. But to make sure that we are using the correct ones, we are going to create a circle around them. So we will write here cv2.circle, and in the circle we are going to say that we want to put it on our image, and then we have to give in the center value. Now here what we can do is we can create some variables so that we don't have to write all of this again and again. So we can write here x1 and y1 is equals to LM list at number 4, and we need the first element of it. So this is the ID number 0, then this is number 1 element, which is the x, and this is the second element, which is the y. So we need the first element as x, and then we need the second element as y. And then we can copy this and we can do it for the index as well. So we will write here, this is 8 and this one is 8 as well. So now I can simply write x1 and x2, x1 and y1. And then we are going to write the radius, let's say 15. And then we will give in the color, let's say 255, 0 and then 255. And then we will write cv2 dot filled. Okay, so we can copy this for the other one and we can paste it here and we can write x2 and y2. So this will create two circles at that point. So if we are getting the correct points, then it should draw on the thumb and the index. And there you go. So now you can see that it is drawing on the thumb and the index. So this is good. Now the next thing we can do is we can create a line between them. So we can write here cv2.line, and within the line we will give in our image, and then we will give in x1 and y1, and then we will give in x2 and y2, and then we will give in, what else do we have? We have the color, so 255, 0, 255, and then we have the thickness. So let's try that out. There you go. So now we are getting the line as well in between. Okay, so next thing what we have to do is we have to get the center of this line. So we can do that simply by writing here cx and cy is equals to x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So we can simply write it like this, and this will give us the cx and cy, and we can put a circle for that as well. So let's write here cx and let's write here cy. So let's try that out, and there you go. So now we are getting a nice circle in between. So this is good. Now next thing we can do is to find the length. So this is the most important thing. We need to know what is the length between these 2 points, or what is the length of this line. When we know the length of this line, then we can change the volume based on that. So what we can do is we can write our own function, and we can do a little bit of maths to square it and then square root. But instead we are going to import math, and within math we have the hypotenuse function, so we will use that. So we will write here that our length is equals to math dot hypotenuse, and then inside that we are going to write x2 minus x1 and then y2 minus y1. So that will give us our length. So we can print it out. So let's try that. I think we are printing something else as well, so we need to remove that first. Okay, let's try it. Okay, so here you can see that when I increase the distance, the value increases. When I decrease it, the value decreases. So the maximum you can say is around 300 something. So we can say, let's say it's 300, and the minimum, let's say, is 50. Okay, so this is the maximum and minimum that we have. So one thing we can do is we can write here that if our length is less than 50, then we want to change the color of our center circle. So let's make it green. So this will give it like a button effect. So when you're pressing it, it changes. So here, let's let it load. Okay, so here when we come closer, there you go. So now it actually feels like a button, and it is very soothing. I don't know why, but it's pretty cool. And it's quite fast, so it is good. So this is good, and now what we can do is we can change the volume based on this length. So how can we do that? Well, we have a couple of libraries that can help us with this. The one that I found was PyCo. I don't know why it says Co, but it is developed by Andri Miras. So thanks to him for developing this awesome library, which allows us to change the volume of our computer. So it is under the MIT license. And if you go down, you have to just write pip install PyCo, and then you can use this code as the template. So I will copy this because I'm lazy, and I will paste it here. Okay, so now what we have to do is we have to simply go to File, Settings, and we will add PyCo. You can do pip install as well. It's the same thing. So we can click on PyCo and we can click on install. So that is installed and we're good to go. If we go back, you will see all the errors are gone. So we will copy the imports and we will cut them and we will paste it at the top. And the rest of it, we are going to see what do we need and what we don't. So what we can see here is that we have the volume get mute. So this seems like the initializations. So we are not going to change anything there. Then here we have volume.get mute. We don't want that. Then we have get master volume level. Do we need? I don't think we need that. We might need the volume range. And then we have volume.master volume. So we can set the volume. So before we set it, let's see what is the range. So I can print this. And there you go. So our range is from -65 to 0. So this is our range. So we are going to use these two parameters. So 0 will be maximum and 65 will be minimum. We will ignore this value. So if I set the volume as -20, let's run it and see what happens. So right now it is at 26. The volume goes to 26. If I set it as, let's say, -5, let's see what happens to the volume. It goes to 72. And if I put it as 0, then you can see it goes to 100. So this is basically the idea. So what we can do is we can get the minimum and maximum range. So we can write here that our volume range is equals to volume, get volume range. And then we will say that, or we will keep it like this. Let's keep it like this. We can take the values later on. Or I think it's better to write. So we'll write here minimum volume is equals to volume range at 1, was it? Yeah, at 0. And then maximum volume is at 1. So this is our range. Okay, so now we can use minimum volume and maximum volume instead of using this. Okay, so what is the next thing that we need to do? Now the next thing is we need to convert our volume ranges. So as you saw that our minimum and maximum was 350. So we were getting, let's write it after the length. So here we know that our hand range was from 300 was the maximum and the minimum was 50. So it was from 50 to 300. Now we need to convert it to our volume range. So our volume range is from minus 65 to 0. So we need to convert this range into this range. So in order to do that, we have a very simple function in NumPy. So we have, did we include? Yes, we included NumPy. So in NumPy, we can write here volume is equals to numpy dot interp, and inside that we are going to give in the value that we want to convert. So we want to convert the length, and now we have to give in the range. So our range was 50 to 300, and then now we have to give in the range to which we want to convert. So our range here is the minimum volume, and this will be the maximum volume. So let's print this out. So let's print the volume. So let's remove that. And let's see if this works. So right now it's minus 25. If I go down, it goes to minus 65. So here our volume is 0. And if I go up, you can see it should go till 0. Yeah, there you go. This is the maximum. So this is good. If you are a little bit confused, you can write the length here as well. So the length and the volume, you can see side by side. We can make it, let's make it integer. That doesn't give weird values. So yeah, here you can see when we have the minimum volume, then it gives us minus 65. And then when the length is maximum, it gives us 0. So this is exactly what we wanted. So now that we have converted this, we can simply send it to our master volume. So we have the function here. We can actually remove it from here. And we can go down, and after the volume, we can paste it here. So set master volume level, we are going to set it as our volume. So let's try this. So I will open up my volume and let's try this. There you go. So if I go to 0, it goes to 0 as well. If I increase the length, you can see, and now it goes to the maximum. I think 300 is a little too far. No, it's fine. You can see I can change the volume from here. You can make it a little more smoother as well by changing the range of these two over here. And even this you can play around with, because I can see it's not very proportional. So you can play around with those values to make some changes. Now, the last thing we can do is we can show the volume bar on the side so that it looks a little bit nice to see what is the volume at any given point. So what we can do here is that we can create a rectangle. So we will go down and we will write here cv2.rectangle, and we will put it on our image. We will give it the initial position, and then we will give it the ending position. So we will give that, and then we will give in the color. So let's make it green, and then we will write cv2.filled. So this is the idea. So the width of our bar is basically 85 minus 50, which is 35. So if we run this, there you go. So this is our bar. And what we have to do is we have to remove the fill. We don't want a fill. We want, let's say, 3. So let's run that. Yeah. So there is our bar. And then the next part will be filled. So the next part here, we will copy this. And now we will give in the volume. So we will say that our width is the same, but the height will be different. So we will write here integer our height. So volume of this. And do we need to change anything else? Not really. So here we need to change cv2 dot filled. So if we run this, volume is not defined. Oh yeah, volume is not defined here. So we can write here volume is equals to 0. Okay, there you go. So now you can see that it's going out of the what do you call image. So if I try to change, let's try to change. Does it change? No, because it is too big for us. So what we need to do is we need to convert our range again. So in this instance, our range is from, let's say 400. So 400, let me show you here. So 400 is at this point. So this is the height 400. So when our volume is 0, it should be 400. And at this point, we have, what do we have? We have 150. When the volume is maximum, it should be 150. So our new range, so we can write here that this is volume for the bar. So we will write here, it's again 50 from 300 till 300, but the minimum now is 400 and the maximum is 150. So instead of volume, we will send in volume bar. So let's run that. Okay, now volume bar is not defined. So we need to write here volume bar. And let's do volume as well. Volume is equals to 0. Okay, let's run it. Still the same. Why? Where did I make a mistake? Volume bar is from... So where is the issue? Let's run it again and see. If I put my hand in. Okay. So the first value is wrong. So we need to go up here and volume bar should be 400. So it is at the first point, it should be 0. So our 0 is at 400. So there you go. So now if I bring in my hand and now if I change, you can see it changes the value. There you go. So the last thing we can do is to add a percentage at the bottom. So we can copy this and we can paste it here. And in the text, we are going to give in our percentage, but again, we don't have any percentage. So we can create another conversion here. We can write here volume percentage is equals to 50 to 300. And now it will be from 0 to 100. So we need the percentage of that. And then we can write here that our volume, this is our volume. Should we write volume or let's just keep it like this? And then we can write here volume percentage and then we can write percentage in front of that. But the location, let's put it for 40. Let's keep it at 40 and then let's put this as 450 and let's keep the rest same, or let's change the color. Let's make it green so it matches that. So let's try that out. Okay, volume percentage. I always forget this. Volume percentage is not defined. We need to define it as 0. Or should it be 0? Yeah, it should be 0. Okay, so 0%, 64. It's hard to see this color. Let's change the color completely. So let's keep it as blue. So I will copy the blue color. Where is it? From the FPS. And we will put it for all of these. Okay, let's try it again. Yeah, now it's much clearer. So here we can see, so 100 is a little bit hard to reach. So instead of 300, I can make it 250, for example, 275. But now you can see the percentage is changing. Let me show the volume bar. And you can see here that the percentage is changing. So that is pretty good. So as you can see, it is very easy to create a project once we have our module ready. So you can import this module into a lot of different projects and you can work with it. And all you need to do is you need to create an object. Where is the object? This is the object that you have to create. And after creating the object, you can find out all the different landmarks that you need from the landmark list. So this is it for today. I hope you have learned something new. If you like the video, give it a thumbs up and don't forget to share this video with your friends. Keep spreading the knowledge and hopefully we will have a complete community of computer vision and OpenCV and whatnot. Make sure that you subscribe if you haven't subscribed, and there will be more videos on pose detection and facial mesh and whatnot. So make sure you subscribe and I will see you in the next one.